evening. Check, check. It is the green one. Test, check. Green means go. Well, I'd like to welcome everyone this evening. Thank you for coming out. Tonight, we have a special guest speaker who's here to give us a 3-part seminar on the gut-brain connection. How many here have heard a lot the last couple of years, and some of it conflicting information about your gut and what you should be doing to help your gut? Because like 70% of our immune system is found in our intestinal tract. And so my teens and I this past spring had opportunity to go up to the Seattle area for something called the MindCure Conference. And there were several speakers there talking about health and mental health and different things that we can do, natural things and just things to help us along those lines. And half of the speakers I had just had the opportunity to go and see down in Weimar, California at something called the EQ Summit. But the other half were people that I'd never heard before. And tonight's speaker is one of those speakers that the first time I had ever heard of him was at the MindCure Conference. And the information that he shared on this topic I got really excited because there's some things that I've had some questions about. There's things that, I've had beliefs about, and some of the things that we hear in the world kind of was opposite of that. And so Ron was actually able to help answer some of those questions. And I was speaking to him this evening, and he said that was actually the first time that he had done this topic. And actually between May and now, he's been able to find more things and add some things to it. So I'm just really excited to have him here tonight and have him share with us so that we can learn a little bit more on how to be healthy. Because when our gut is healthy, another thing that gets healthy is our minds. And so we live in a world today where there's a lot of crazy stuff going on. So it's good to have a clear mind to be able to understand what's going on and discern between different things when you're trying to figure it out. So the clearer our mind is, the more we can understand. I'd just like to start this meeting with a little blessing on our speaker, and then I'll invite him to come up and leave the rest of the time to him. Dear Heavenly Father, we thank you for traveling mercies for the MeinHardt family to come and share with us, and I ask that you be with him tonight and help him to bring clarity to us for some of these subjects that we hear varying and conflicting things about. And just thank you for your love for all of us. In Jesus' name I pray, amen. So come on up, Ron, and present the gut-brain connection to us.
Hello, everyone. How's everyone doing this evening? Wonderful. Did you enjoy the wonderful meal? Okay, great. Well, now you're ready to learn, right? To learn about what's going to happen with that meal over the next 24 to even 72 hours. As it makes its way through our digestive tract, and it interacts with something that we're going to learn about today, which is bacteria and the microbiome, the whole nother world that researchers are discovering that lives inside of you, okay? So we're going to learn about a little of this tonight. As was mentioned before, this is part 1 of a 3-part series, and I hope that you enjoy what you're about to hear. And I want to tell you, even if you come to all 3 parts of this series, which I highly recommend, it's still only going to scratch the surface on this topic. It's amazing how much research is being published. It's like almost as if a snowball is rolling and getting larger and larger and larger. And just 15 years ago, we had no idea about many of these things. But now it's amazing the insight we have looking at the scientific literature, where we can actually understand not only the bacteria that live in our colon, what organism, what phylum, what family they're in, but also what they want to do for us. Because I'll submit to you, not every bacteria is a friendly bacteria. Not every constituent of our microbiome really should be there. So this is the gut-brain connection, and we're going to go ahead and go on to our first topic, which is entitled Of Bowels, Brains, and of Bowels, Bacteria, and Brains. First of all, there are many other organisms that live in your intestines besides just the typical bacteria that a lot of us think of. There are molds, yeast, even a few, hopefully not a lot, of parasites. And some of these things really shouldn't be there, but some of these things are more in a gray area. We don't really know if they belong there. And I'll submit to you, scientists, in a lot of ways, the microbiome, and when I say microbiome, I'm just talking about the bacteria's home there in your intestines, is in many ways a gray area for researchers. Why is that? I'll submit to you, it's because of a huge misunderstanding that occurred in the early part of the 20th century. Read you a quote from a very interesting article written about 1920. It says, "It is probable that future years will show that many of the diseases classed today as of obscure origin will be understood to be directly or indirectly due to states of chronic toxemia from the intestinal canal. To be directly, there it is again, to be directly or indirectly due to states of chronic toxemia from the intestinal canal." So, that must be pretty important, right? It's repeated. Is this wisdom? That was from the 1920s. That was almost 100 years ago. Do you believe that science is validating this, or is it invalidating this hypothesis? Validating, okay. I think we're on the right track, but suffice it to say, this information, even though we may identify it with it today, was very controversial when it was published. In fact, there were kind of dividing lines drawn between individuals, physicians, and researchers who believed that either there's nothing important that lives in the colon, and there's no kind of interaction in terms of how it affects our body, our health, and so on. And then there's the other group that said, hey, it's hugely important. Of course, this gentleman right here was in that number that thought that there was something to this concept of promoting health in the intestinal canal. Now, I'll submit to you, I said there were two groups. Well, there really was a third group. And it was the group that said, hey, because it's so important and we don't want these bacteria producing these toxins, we're actually going to say that this is probably the most important thing in medicine. And they elevated it to a level of importance that I believe it didn't deserve. You know what their thought was? That these bacteria were producing toxic byproducts, so let's actually take out the colon altogether. And they actually performed thousands of colon resections and took out the large intestine because they thought that was the cure. Now, what happens when you have fanaticism with truth? What happens? It gives truth a bad taste, right? And so it gave more ammunition to those individuals who said, hey, it doesn't make any sense. None of this makes any sense. Let's just throw it all out. And eventually that's just what they did. By the mid-1930s, if you talked about toxemia coming from the intestinal canal, you were labeled a quack. And that continued up until, believe it or not, the early turn of this century. Can you believe that? It is kind of interesting that it's happened, but I'm glad that we are gaining an understanding of these things now. There are some physicians who are way ahead in many ways of where we are even today in terms of their knowledge, their understanding of the microbiome, how the bacteria affected us, how they interacted not only with the small area there in the large intestine, but how their byproducts influence the whole body. One of these physicians was Dr. John Harvey Kellogg. Wrote many books on the subject. Not everything I agree with that he's written, but I think in his earlier understanding of these things, he was quite advanced. There were other physicians, as I said before, who were opposed to this, and there was one prominent physician in particular who kind of was the physician who put all this aside. His preeminent decision to downgrade the colon to an organ that's not really important, don't really need to know what's there, happened in the 1930s. And people cited him up until even the 1960s, 70s, 80s, and even the 90s, saying it doesn't matter what's in the colon. You've heard of leaky gut? If you say leaky gut around a medical professional, especially 20 years ago, they would think, oh, it doesn't make any sense. That's just, anecdotal. But I'll tell you, if you say impaired intestinal permeability around a medical professional, they'll know exactly what you're talking about. So a lot of us have this understanding that, what is inside the colon, if it leaks out, it causes problems, right? It's the same thing whether you have leaky gut, that a layperson would refer to it as, or the impaired intestinal permeability. It can cause problems. And scientists are finally identifying that possibility. Not only the possibility by research and by statistical analysis, they're showing it's causing quite a bit of problems in this country and in especially the westernized world. One of the most profound related diagnosis to this impaired intestinal permeability or leaky gut is the diagnosis of depression. In fact, I told you about the colon resections that were being done in the early 1900s. Well, those were done at mental institutions because they thought, well, hey, if they're depressed, severely depressed and anxious, we do think there's a relationship between the colon and this depression. Let's just cut out the colon altogether. Now, they were doing a lot of other strange things at mental institutions, lobotomies and so on. So it doesn't surprise me that they would be doing something like this. But I'll submit to you, just because they were going to the extreme and taking out the colon doesn't mean that there isn't a relationship between depression and anxiety and even mental function and the gut. Now, it would be important for us to understand this relationship, seeing that over 26.2% actually of U.S. adults suffer from a diagnosable mental illness in one calendar year. That's over a quarter of us suffering from mental illness. Sometimes depression comes into our lives and it doesn't seem to go away, even with proper thinking. It could be there's an organic cause, there's something going on in the body that's bringing about this state of feeling and thinking. Now, that's not saying that counseling and that kind of thing is not helpful, but sometimes we have to go even beyond counseling to see what physiologically is going on in the body. Could there be something or some organ that's unhealthy? And I'll submit to you, the least of all organs could be the culprit, the colon. Some people think, oh, the colon's not important. I hope that after this series, and I hope that you can come out to all 3 meetings, after this series, you're going to have a newfound appreciation and even love for your colon, okay? Because there is a relationship between our mood and our gut bacteria. So, that being said, we're going to have to go to a classroom right now. And you all are the new students, okay? I'm only going to go as far and as fast as you can go. So a lot of these words we're going to be discussing, I can't abbreviate them. I'll make them even more confusing if I abbreviate these things. So we're going to have to use some big words here. But I'll tell you what, I'll speak them softly, nice and loud, but slowly so you can understand them, okay? And don't worry, I wasn't born understanding these things either. Everyone who's learned these things has to study. And so we're going to study a little bit together, okay? But it's going to be exciting. It's not going to be like your normal classroom setting. I promise you that. Okay, are we ready to go into our study of bacteria? first of all, let's look at some of the designations of bacteria, the classifications and the naming system of bacteria, so you won't be overwhelmed when you see some of these things repeated. Different types of bacteria. We have the cocci or cocci bacteria that are just basically this round shape. They can come in different configurations. You probably have heard of this one, right? Staphylococci. It's a common skin bacteria, but you definitely don't want to get the MRSA variety, the antibiotic-resistant variety of this internally. But you have some other bacilli over here. These are kind of like your cylindrical type bacteria. Some of them will have flagella, which they use for motility, for moving around. You've ever heard of salmonella? Typhoid fever, this is the Salmonella typhi. This is the organism that causes that typhoid fever. You know, there are bacteria actually that can protect you from typhoid fever. It's quite amazing, at least according to the research. Okay, and we have some of these Clostridium. This is the botulinum. We don't want that in our system in large amounts. We have some others here that we'll talk about in general, but for the most part, I want you to understand that the bacteria are given different names oftentimes because of their shape and their configuration, okay? But there are other things as well. They produce different byproducts. They're not all the same. Now, where can we find a good amount of these bacteria? Where do you go to get probiotics? Anyone? Okay, you go to the store? Okay, all right. The store, the supplement store, right? You know what? All of you are walking around right now with a good source of probiotics. You know where it is? Say ah. Scientists have discovered over 200 strains of just lactobacilli. Okay, you know the cylindrical type, so lactic acid producing cylindrical type bacteria living there in your mouth. Over 200 in the normal healthy individual. That's quite interesting, considering that lactobacilli, at least some of them, are some of the most healthful and health-promoting probiotic bacteria. So where do you go for your probiotics? Where's your first source? It's right there. It's in your mouth. That's a good question. We're going to examine that concept, okay? The question was, how do they get there? We're going to examine that in just a minute. So if you think that you need probiotics, first of all, look within your mouth, because honestly, we all have them there, okay? Now, the good question that was asked is, how do we get them there? And we'll actually touch on that in just a few minutes. All right. Before we go to that question, though, I want to give you a little bit of anatomy and physiology so you understand a little bit more about the digestive tract and understand a little bit more about that symbiotic relationship that the gut bacteria has with us. Believe it or not, the microbiome accounts for up to 3% of your body weight. Can you imagine that? Now, how many of you would like to lose 3% of your weight real quick? Okay, you know you can do that, but I wouldn't recommend it. It takes a long time to build up a wonderful plethora of symbiotic bacteria, of health-promoting bacteria there in the colon. But one round of antibiotics can wipe them out. You know that? So there are a lot of researchers actually that are really hesitating now. We used to think that if you had a bacterial infection, right away, get your antibiotic, right? Or even a viral infection, you'd be sent home sometimes with antibiotics to prevent the secondary infection. But now, I'm sure many of you are aware that even physicians are much more hesitant to prescribe antibiotics. Why? Because we're producing antibiotic-resistant organisms, and we're running out of antibiotics that even work against these bacteria, not to mention what we know now about the microbiome. So it's very, very important that we be, I would submit to you, more cautious. I remember growing up, and I just had these frequent, recurrent sinus infections. And it got to the point where I realized that if I had an antibiotic, my sinus infection would clear up faster. And so I knew all the words to tell my family doctor for him to write me a script. Now I was a young man. Oh, doctor, it's green. The mucus is green. It's inflamed. It's hurting. It's warm. Right away, he'd write me one. But you know what? I was ignorant. And many of us, we want the antibiotic right away. We think that's the most important thing. But if your physician is hesitant to give you the antibiotic, that's a good thing. A lot of times we don't necessarily need it. And we could possibly allow that infection to be, maybe if it's viral, to heal naturally, right? And even if it's bacterial, we could maybe wait a little bit. Of course, up to your physician's discretion. But don't feel like we have to demand those antibiotics, because I'll submit to you, in doing that, we could be causing more harm than good. Okay? So, consider this. If your microbiome is about 3%, up to 3% of your total body mass, if you had 150 pounds of weight on your frame, you would have anywhere from 1.5 to 4.5 pounds of these bacteria in your colon mainly, but also maybe a little in your small intestine. Can you imagine that? And within that small package, that's only what? 3% of your body weight, right? Only 3% of your body weight. There are more cells there than you have human cells, because these bacteria are so small, so much smaller than many of your cells. So in a sense, there are more of them than you, more of them than us. Isn't that amazing? Now, that sounds like that these things then might be important to us biologically speaking, right? If we have so many of them, and I'll submit to you they are in many different ways. Okay, now there are as many as 500 separate species that have been identified, these organisms that commonly inhabit the human intestine, but some of them, as I said before, are much more healthy than others. So let's go through and try to understand a little bit more about the microbiome, and let's start with the door to the microbiome. Now, we talked about the mouth, right? And the question was asked, where do those bacteria come from? Well, where does your food come from? Because wherever the food came from, that's where those bacteria came from also, in most cases. So when we chew our food, one very important thing for us to do is to mix it thoroughly with our saliva. It's so important. It's the most underrated activity in the Western world, chewing our food. Studies have found that when we chew our food properly, we even are more satisfied. We'll actually eat less, and we'll be more satisfied by chewing our food properly. Our digestion will work better, okay? And knowing that there are so many of those lactobacilli that are in our mouth, we're going to be mixing them thoroughly with our food as well. So what does that mean? We've just cultured some probiotic bacteria and put it into the stomach. Sounds exciting, right? Okay, now if you thought that was exciting, wait till we talk about the stomach. The stomach really is the door. There are many bacteria that can enter in the stomach, into the mouth, that I'll submit to you are not really necessarily designed to go into the rest of the body. And the door, or the gatekeeper of all this, is the stomach. How's the stomach a gatekeeper? The acidity. The stomach's pH is about 2, ideally. So a pH of 2, that's a very, very hydrochloric acid, very, very strong acid. You wouldn't want to get that on your skin. In fact, the stomach doesn't even want to get it on its surface. So it secretes a large amount of mucus to protect itself from being disintegrated by its own product of digestion. Now, that being said, there are many bacteria that do not survive this acidic pH. Many of them are destroyed. And many of those disease-causing bacteria in particular, those bacteria are destroyed. You've heard of Clostridium difficile, C. diff. if you're in the medical arena. I know myself as a RN, we had quite a few people that would come in with C. diff, and we would know it. Even if we didn't have the diagnosis posted on the board, we would know it within a few hours of being in their room. Chronic diarrhea, certain smell they would get, just not a very nice infection. Studies have found that when we shut off the acidity here in the stomach, we greatly increase our risk of C. diff infections and of small intestine bacterial overgrowth with organisms that should not be there. So how do we turn off the acidity? Well, stress actually turns up the acidity. We pump a whole bunch of stomach acid there in the stomach to kind of, as a protective mechanism, whereby we can keep some food there in the stomach and not worry about it. Doesn't ferment as readily. Anxiety could cause issues with stomach acid. If you're secreting stomach acid all the time, usually what will happen with an organ, if it over-secretes something, what happens? It stops effectively secreting it. And so anxiety, chronic anxiety, could lead to even things like this. But the most common issue here with decreasing the acidity of the stomach or increasing it, making it more alkaline, is going to be your antacids or your proton pump inhibitors, the things we take for GERD and for heartburn. These things actually have been linked to increased risk of infection in the small intestine with bacteria that should not be there. So if at all possible, that gatekeeper should be empowered to say, hey, you don't belong here. I'm going to get rid of you so you don't have to be there in the stomach, in the intestines. Very, very important. Now, it's interesting. Some of those bacteria that live on plants, the lactobacilli, 35% of lactobacilli that are found on plants can survive the acidity of the stomach, and they can make their way into the small intestine. So the question was asked, where do they come from? Where do these bacteria come from? From the food that we eat. And then we swallow those bacteria. They go into the stomach. The stomach is the gatekeeper. It should be keeping the bacteria out that shouldn't be there. Now, this is on a general sense. It's not going to keep all those bad bacteria out. But it's going to help kind of weed out some of the more disease-causing organisms. Yes, we had a question over here. Okay, the question is that assuming that we're eating it raw? Well, I'll submit to you, if you cook food, plant material, at high temperatures, you will destroy most of the bacteria. There's some bacteria that are a little bit more resistant to heat, but the vast majority are going to be destroyed at a normal cooking temperature. So it is a good idea to have every now and then some raw fruits or vegetables. Why? Because they are going to have inhabiting them these bacteria. We'll talk more about that in a moment. Let's go on to the intestine before we do, though. Let's talk about this little organ right here, the duodenum. It's just not really an organ, but it's the beginning part of the small intestine. And there is a sphincter right here, a little muscle that constricts, that basically waits for the stomach to do its job. Once it opens up a little bit, samples some of the food that's coming out, or the chyme it's referred to at this point, it samples it and it can tell whether or not the stomach has finished the digestive process. Once it's finished, then it allows the food to pass through this little arch here. And when it comes down the arch, something else happens. That is, the gallbladder, which is the accessory organ of the liver that holds bile, contracts. What does that do? All of a sudden, you have bile secreted on that very acidic chyme, the food. An alkaline substance is released, neutralizes the acid, helps to break down the fat, and also kills some of those other bacteria that you probably shouldn't have growing in your small intestine. So there are two things that can kill bacteria there in the stomach, the acidity and then the rapid pH change to a more alkaline environment. And so this combined effort is really your gatekeeper. Now after this, you have the food entering into an area where a lot of absorption takes place. Most of your absorptions of nutrients is going to take place in this, the duodenum and the jejunum, the first two sections of the small intestine. Over here, you still have a few absorptions of nutrients, in particular some vitamins. Even B12 is absorbed over here in this part of the latter part of the small intestine. So, that being said, let's consider something. If we are to consume some plant material, let's say, and we allow it to go into our stomach kind of weeds out the good and the bad, and it goes down in here, goes over into the small intestine, then eventually makes its way into the large intestine. This is really its home right here. This is its home. This is where it's going to be allowed to grow and proliferate in a very, very fast amount. Now, you will have some growth occurring in the small intestine. As it moves down to the end of the small intestine, that food that you have chewed so well, right? And mixed thoroughly with the even just the probiotic bacteria that are there in your mouth in a dormant state, they're going to wake up and they're going to start munching on that extra glucose and those extra food nutrients that you have, until down here in the large intestine, there's some things they want to give back to you. You know where B12 comes from? Bacteria. Cobalamin is the compound that's produced by bacteria. Now, if you want B12 and you go to an animal source to get it, you know where that animal got it from? Bacteria, ultimately. So, studies have found that these bacteria, as they move along here, they start to produce cobalamins. And by the time they get down here, you know what happens? There's an organ, well, this part of the small intestine, the distal part or the latter part, it's ready to absorb. It's where that absorption of B12 takes place. So I'll submit to you, we were designed to absorb B12 in this manner. But 50% of Americans are deficient in B12. 60% of vegans are deficient in B12. Now, a lot of people say, well, you're vegan, you've got to take B12. I'll tell you, you're American, you got to take B12. But the best place to get B12 is from, I'll submit to you, the bacteria, because they're the original producers. I believe that if we ate more healthfully, more of these raw fruits and vegetables, and we chewed our food thoroughly, we would see less and less of B12 deficiency. Because we were built to have a symbiotic relationship with these bacteria to allow them to give us these good things. Now, sometimes the bacteria, they won't give us the B12 or the cobalamin. They'll actually use it themselves, and they'll fight each other with it. So it's also important for us to know what food combinations work better together for producing a better bacterial outcome. And we'll talk about that more on that tomorrow. But let's focus on a few of these bacteria, and let's see what some of the health benefits are that they can give us. First of all, the bifidobacterium, very, very well published, well studied bacteria that seems to like to share his domain. The bifidobacteria, if you have higher amounts of bifidobacteria, you know what else you have? You have more species of bacteria in general across the board, because this bacteria likes to share its domain with other health-promoting bacterium as well. The bifidobacteria have been known to help with immunity and all sorts of things. But we won't talk too much more about them tonight. We'll talk more about them tomorrow. Let's talk about these ones right here, E. coli. You've heard E. coli have been in the news lately, right? Even going back into the 80s, E. coli contamination of foods, of burgers, of these types of things. You've heard of flesh-eating bacteria, right? There are only certain strains of E. coli that are actually disease-causing. Most of the E. coli that we have is actually helpful. They've actually found that when we have colonization of E. coli, it actually can protect us from certain pathogenic bacteria that could enter into the colon. So it's not a bad thing to have E. coli in the colon. And then we have the lactobacilli right over here. We're going to spend quite a bit of time on lactobacilli tonight, so I'm not going to go too much in depth with these. But suffice it to say, these are among the good bacteria. Now, we have this little graphic here listed some of the disease-causing bacteria that can colonize the colon, and you see C. diff right there, right? There are some bacteria, obviously, that we should never have in the colon. They're going to cause disease outright. But I'll submit to you, even some of the bacteria that we consider to be probiotic, you know what that word means? For life. Probiotic bacteria, they're not the most ideal bacteria or other organisms, even for that matter, for us to have in our colon. So how do we tell the difference? Well, we can look at studies and we can find out things like the immune boosting functions of some of these organisms. This is a little patch of immune system laden colon. And you can see here we have some of these cells. These are dendritic cells right here. They have these little feelers out where the food is passing through. They feel some bacteria here in this little point in time, and they activate a lot of these immune cells. They actually produce something called interferon when some of these bacteria pass by. Now, in this study that this is documenting, actually the strain was Lactobacillus plantarum. So Lactobacillus plantarum actually initiated a release of interferon and interleukin-12. Both of these are very important for fighting viruses and cancer. So these kind of bacteria, they need to be there for many purposes, for many reasons. Some of them may just save our lives in the long run. Let's focus our attention right now on lactobacilli. We're going to focus on a lot of different organisms. Don't worry. We're not going to get to all of them tonight. We'll talk more about them tomorrow in our last session as well. But let's talk about lactobacilli for a moment. When you think of lactic acid, what do you think of? Good or bad? Most people believe that lactic acid is the cause of muscle soreness, right? I used to think that that's what I was educated under that premise. But if you study the research now, that was called, they kind of call that pseudoscience now. It was based on a false premise. What they realize now is that lactic acid in the body, in the pH of the body, turns very quickly into lactate, and it doesn't cause irritation to the muscular tissues. That delayed onset muscle soreness that many of us feel the next day after exercise is more readily due to microtrauma, or these microscopic tears in the muscle fibers. That causes inflammation. And so we used to blame it on lactic acid. Well, lactic acid kind of got a bad name because of that blame. But I'll submit to you, lactic acid can be beneficial. There are certain types of it that are not so good. We'll talk about that in just a few minutes. But let's talk about, first of all, the lactic acid that your muscles produce. This is known as L-lactic acid. What did I say? L-lactic acid. So this is the one that we love, right? L for love. Why do we love lactic acid? Well, I'm going to give you a few reasons. If you don't like lactic acid, I'm going to give you at least 3 reasons that you should love this form of lactic acid. First of all, how many of you value your neurons, your brain cells? Okay, wonderful. Most people's hands went up. That's good. And even if you don't value them, I want to submit to you that it's very important for us to hold on to all the neurons that we can. Because we're in an environment in this world today where we're constantly being bombarded with toxins, with whatever it may be, environmentally speaking, that could be destroying brain cells. But we want to keep them functioning properly. Interesting study that found if these mice over here were fed lactic acid, whereas these mice over here were not fed lactic acid, they both could run through the maze equally as well. Okay? Didn't seem to be any difference until a traumatic event occurred. And this was orchestrated by the scientists. They took a mallet or some type of instrument, and they gave these mice over here traumatic brain injuries. These ones were taking lactic acid, right? Then they gave these ones over here that weren't taking lactic acid traumatic brain injuries. And they put them back into the mazes, this group over here with the traumatic brain injury that had the lactic acid, and this group over here that had no lactic acid, just regular mouse feed. and brain injury as well. You know what happened? Over here, the mice, what do you think? Could they make it through the maze? No. They showed brain injured results. They couldn't. They were just spinning around in circles, so to speak. But the group over here amazed the scientist because they ran straight through the maze again, showing no residual effects from traumatic brain injury. So the scientist said, hey, it's the lactic acid. It's neuroprotective. It actually protects the neurons, protects the brain from damage. Now, where do we get L-lactate from? I just told you a few minutes ago. We get it from exercise, right? Exercise is neuroprotective. There's one more reason for us to exercise, right? If you don't have enough reasons to exercise, it actually will protect our brains, okay? When we get L-lactate from our muscles. Now, when do we get L-lactate? Is it with long distance running or just 5-second duration? It's usually more in the middle with more of that. Basically, we overstretch the muscle's capacity for its use of creatine, which is the short-term bursts of energy. We go into a stage where the muscle can't get enough oxygen to burn the sugar in that normal way, the aerobic way, so it has to switch to anaerobic metabolism. You know what another word for that is? Fermentation. Some people say fermentation, that's a bad word. No, don't eat anything fermented. Well, I'll submit to you. Not all fermentations are the same. Not all fermentations are going to be negative. And this fermentation, we know it's important for us because even our muscles do it. This is a symbiotic fermentation, L-lactate production, because it protects our brain for one thing, right? But let's see. If that was the only study, you could make a case that maybe that's not so important. It just protects the brain a little bit. But here's another study, or two studies. They took these mice, and they didn't feed them the lactic acid. They actually had them in this controlled swimming environment where they were just doing this. It wasn't a doggy paddle. I guess it was a mouse paddle. And this continuous flow of water, like the never-ending pool that you can get. They were in this pool, and they probably wanted to get out, but they just had to stay. And they were exercising, right? They turned up the intensity, and these mice were producing lactic acid. And I told you lactic acid turns into what very quickly in the body? Lactate, okay? And that has nothing to do with milk. Sometimes it's confusing, I know. They actually named lactic acid bacteria lactic acid producing bacteria or lactic acid because it was first derived from milk, or the bacteria was found in milk. It doesn't really, there's no connection besides that. It's just in name. But these mice were producing lactate. You had these male mice that were swimming over here, and as their lactate increased in circulation, something else also correspondingly increased, in the same growth rate as the lactic acid. You know what it was? It was the most important male androgen, or male hormone. It's known as testosterone. So what they found was that lactate increased serum testosterone levels. Now that may not seem like a real important thing, but many, especially elderly Americans, male Americans, are low in testosterone. And low testosterone is a huge predictor of mortality, of early mortality, of dying early. So we need to have a certain amount of that testosterone. Yes, we shouldn't have too much of it, but most of us don't have that problem. Most of us have too little. So mice can help produce, or exercise can help produce this lactate, and the mice proved it there. But what about females? You don't want to necessarily have high levels of testosterone, right? Not generally the desire of most females. But there is something that you may want. In fact, there is something that I'll submit to you is the similar hormone as testosterone for females. It's the one that it seems like many, especially elderly females, are low in. It's called progesterone. Ever heard of that? Okay. Now, when estrogen and progesterone get out of balance, you have all sorts of problems, and that seems to happen a lot after menopause. Now, that being said, I want to tell you about this study with mice. These female mice were put into the swimming pool, and they started swimming, and they had these spinal tap devices hooked up to them. It was very barbaric in some ways, but anyway, they were measuring the amount of lactate that was being produced by this exercise. But you know what? Correspondingly to that increase in lactate, you know what hormone was produced? The progesterone. So besides the story of the mice, if we want to take that information home and use it, what does that mean we need to do to increase our levels of progesterone for females? Exercise. Now, you thought this was only going to be about the gut and the brain, right? I'll submit to you, exercise is good for both, and it helps produce this lactate. But I just wanted to tell you this so you realize, yes, lactate can be a good thing, right? It can be a very important compound in the body. Now, that being said, let's talk about the different forms of lactate, which are L-lactate and D-lactate. L-lactic acid is the beneficial form of this lactic acid. D-lactate, not so much in high amounts. In fact, if we have high amounts of D-lactate and we're diabetic, we are very much going to be at risk for diabetic ketoacidosis. This is the elevated lactate, the elevated blood lactates that sometimes you'll hear is not such a good thing in heart disease and diabetes. It's talking about the D form of lactic acid. Now, there are many of probiotic bacteria that will produce both of these. They'll produce L and D. But on a general scale of things, most of these bacteria, they'll start by producing L-lactate. And then at the tail end of everything, they'll produce the D-lactate. Or at the more advancing stages of development, they'll start to produce more of the D-lactate. Usually it's not going to bother people, but if you have severe leaky gut or severe intestinal permeability, then you probably should really check the probiotic that you're using and make sure it's not producing large amounts of D-lactate, because it could actually more readily cross out into the circulation. Okay? Now, what are some things that produce large amounts of D-lactate? Well, some that we would normally consider to be even healthy bacteria, like acidophilus. Lactobacillus acidophilus produces large amounts of D-lactate. But don't worry, if you don't have severe leaky gut, it probably won't be an issue. And there are plenty of others that can take the place of Lactobacillus acidophilus. So that being said, I want to talk a little bit more about how to identify some of these lactobacilli as healthful. There is a phenomenon that occurs in fermentation that basically is a good barometer of telling whether or not a bacteria is going to be truly healthy or possibly unhealthy to the lining of the colon, which is going to be their primary home. And this is it right here. The homofermenting bacteria and the heterofermenting bacteria. What does that mean? What does the word homo mean? Same, right? So a homofermenting bacteria is going to produce byproducts that keep their environment the same. How many of you have ever rented a house or been landlord to some tenants? Okay? Usually you have to sign a rental contract, right? Where it says, I'm not going to tear down the partition wall in the kitchen and enlarge the kitchen and dining room and paint the house a different color, extend the pavement a little bit further and build a basketball court in the backyard. Now, all these things that are considered major changes to the home, we're not supposed to do that when we're renting a house, right? At least if it's signed in there, we're not supposed to make these changes. Well, what about in the colon? Would you like an organism to go into the colon and cause massive tissue change? possibly massive destruction in the colon, they wouldn't be good tenants, would they? We would want them to be evicted very quickly, right? Well, it's the same thing with these bacteria. The homofermenters are going to be primarily taking glucose and turning it into lactic acid, which I told you could be a number of different, or two different lactic acids or lactates eventually. But they're primarily going to be producing that as their byproduct. That does not necessarily change the lining of the colon. So that's why they're called homofermenters in this case. Okay? What about heterofermenters? Heterofermenters will take glucose and they'll turn it in, or other sugars, and they'll turn it into lactic acid, 2 parts lactic acid in general, 1 part carbon dioxide. Now, who likes that in the colon? Anyone like extra carbon dioxide gas in the colon? Probably not, right? Most people tend to avoid that. And then 1 part ethanol, or pure grain alcohol. Now, what does that do to the lining of the colon? What does that do? Anyone have any ideas? Inflames it, okay? It's very possible. Let me show you a few of these before I answer that question in depth. These are your homofermenters right here. Now, there are many others, but these are some common ones you probably have seen before. These are, yeah, it's a little bit, could we turn one bank of lights on just for this slide? It does. Oh, yeah, turn them off, I mean. Just for this slide, if we can. Okay, a little better. I'll just kind of read some of these for you. Homofermenters right here. Some of them you've seen, like the Lactobacillus acidophilus, right? You've heard of that before. The Salivarius, Bovis, Streptococcus. Probably this one's one of the more common ones as well. This one does better in heat, the Thermophilus. But this one right here is probably one you've seen more than any others, this acidophilus. Now here are some facultative homofermenters. These right here, these bacteria, they're very picky eaters. They don't like to eat sugars besides the actually known as hexose sugars. They're the 6 carbon sugars like glucose, fructose, galactose that comes from milk, those kind of sugars. They'll readily eat, but they don't like the other sugars. But the nice thing about these bacteria is they're, across the board, they're homofermenters. They're not going to produce a whole lot of negative byproducts, mainly lactic acid. But over here we have some that, like these bacteria here, they also like the 6 carbon sugars, and they'll produce mainly lactic acid as a result of breaking them down. But there are more sugars that we eat that go beyond just the 6 carbon sugars. We eat 5 carbon sugars too. They're called the pentose sugars. Ribose is one of them. Mannose is another, found in fruit. Ribose found in anything with RNA or those types of protein sugars. So what we have here is a group of bacteria that can function like these bacteria over here, but then they also, if they start to break down those other sugars, they will produce some other byproducts that are probably not the best. But there's good news about these, about how they produce these byproducts. And I don't know if we're going to talk about that tonight. We'll probably talk about that tomorrow. But suffice it to say, these are a very health-promoting group of bacterium. These bacteria over here, however, they're going to be your bacteria that are going to straight away, glucose, whether it's hexose, 6 carbon sugar, or 5 carbon sugar, whatever sugar it is, they're going to give you some ethanol and some gas along with that lactic acid. Okay? And I'll submit to you, you probably have seen quite a few of these in sourdough bread. Like here's the bacteria that produces San Francisco sourdough. It's fine in the bread, but you don't want it growing in the colon. Why? It's going to raise your colon, so to speak. It's going to produce a large amount of gas. It's going to produce a large amount of ethanol, pressurized solvent, breaking through the structure of the colon. Studies have actually found that we should have, if we want to have good colon health and very little residual leaking out into the circulation, we need to have very tight junctions on the cells that line our colon. But studies have found that ethanol, especially if you have pressurized ethanol with this carbon dioxide, it breaks apart the junctions of those epithelial cells. So that increases the risk of leaky gut or increased intestinal permeability. So I'll submit to you, this group over here wouldn't be a good set of tenants to have as your dominant organism, because they're going to produce these byproducts that could potentially break through and increase the risk of leaky gut or increased intestinal permeability. So that being said, have another example here. Yes, question.
So we're talking about how alcohol from these organisms contributes to leaky gut.
Mm-hmm.
Is there any evidence that just drinking alcoholic products like wine or beer, for example, can do the same thing, or is that different?
Well, there is evidence that if it's given as an enema, it will do the same thing. But if you take it by mouth, it's going to be absorbed before it gets down to the colon. However, it's going to cause damage everywhere else it touches. Ethanol is not good for health. It's a toxin. If you want to kill tissue, dump it in ethanol. It's a good way to preserve tissue as well. So it's not health promoting. You probably heard the old adage, a glass of wine for your heart. It's not the ethanol that's promoting heart health. It's the flavonoid compounds, or the basically what came from the grapes that are potentially beneficial. I'll give you an example here. I do have a few of these in my slides. How many of you like grapes? You know they're good for you, right? There's plenty of resveratrol here, which has been linked to decreased risk of heart disease, boosting of the immune system, is in particular the innate immune response, or the natural killer cells, which go and fight cancer and viral infections. So grapes are wonderful. There's a blessing there in these grapes. But let's say I asked you to give me some money, and I went to the store and got you a whole carton of grapes that look like this. Would you like that very much? Now, you can't see it so much, but this is a rotten grape. Okay? Now, I see some of you thinking that I'm just absolutely crazy. But bear with me for a moment. There's some resveratrol in there. There's some fiber. There's some grape seed extract in there, right? There's some beneficial compounds in that rotten grape. Are you sure you don't want to eat it? Why not? Because there's also some rottenness in there, right? There's ethanol in there. There's acetic acid possibly even in there with the vinegar, where the alcohol has even gone bad and turned into vinegar. And so, suffice it to say, if we really want to get the best health benefit, we want to go to the source, and that's the flavonoids. For instance, here's one. Quercetin. You've probably heard of quercetin before. If you don't like grapes, you can get it from onions. Very, very high content there in onions. Capers, the highest content right here, 180 milligrams per 100 grams. But onions, a great source. Red grapes, white grapes also, very high in quercetin. That being said, though, even taking this alcohol by mouth could be potentially causing some problems. I want to just show you a few studies. A little under 2 glasses of red wine increased duration of GERD by 17 times. That's not 17%, that's 17x. And that's just a small amount of this, right? And consuming less than 1 full glass of wine increased the risk of stomach cancer by 36% compared to non-drinkers. So it's very important for us to analyze the facts. You know, the very first article that published a report of ethanol inhibiting the activity of platelets and basically making the blood less sticky, It was published in the European Heart Journal a number of years ago, a couple decades ago, but they said this as their take-home message. In no way should this justify the use of alcohol for preventative purposes. Why is that? Because alcohol is not healthy for anything. It may kill cells, it destroyed the platelets, and so the blood became less sticky, but that doesn't mean it's good, that it's healthy for the whole body. So ideally, the grapes are going to be the best place to get the beneficial compounds that we find there in the counterpart in the wine. Alcoholic beverage industry loves people to think that, I'll submit to you, because they can sell products. Because people think, yeah, it's actually healthy for me. But either way it comes in, either from the mouth or from the bacteria that are living in the colon, it's going to cause tissue destruction. Okay, now in the studies, what they'll do is they'll take either one or two substances usually. Either they'll take ethanol alcohol or they'll take acetate or acetic acid, and they'll syringe enema this into mice or other animals. You know what it causes right away? Massive colitis. It causes massive inflammation of the colon and leaky gut. And then they perform their experiments on these animals. But I'll submit to you, we could be doing this with just the bacteria that are colonizing our intestines. We could be causing this colitis and bringing about impaired function of our whole body as a result. Here's a study that showed acetate-induced colitis actually promotes colonic tumors. So these things are not really things that we should covet there in the colon. So those heterofermenters, in my opinion, they can decrease. I'd rather have my homofermenters increasing so I can promote things or prevent things like this from happening. Okay, that being said, let's move on for a second here. I want to show you some of these sugars. This is a glucose sugar. I told you it had 6 carbons. They're right here. 1, 2, 3, 4, 5, 6. There's some other sugars here that are notable. These are the other 5 carbon sugars. These are the most abundant in nature. These are much more abundant than those these 6 carbon sugars than those 5 carbon sugars that I was telling you about. So it's not really that important for us, I'll submit to you, to worry about remember that middle category? Those, let's go back up here. These facultative homofermenters, they're going to start eating the glucose and the fructose and that kind of thing first. So some of you might be thinking, well, if they do the same thing that these over here do eventually, should they be in there? Well, because something has to be done with those sugars eventually. But they're going to kind of start on those healthier sugars. They're not going to produce all those more toxic byproducts. Okay? So let's move on here. See any bacteria there? What do you see? Cherries, okay? Do you think it's possible there could be some bacteria there? I'll submit to you, not only is it possible, there are bacteria there. We just can't see microscopically. Even in that smooth surface, it still has pretty a rough surface, even under a slight magnification. And these ridges actually harbor many different types of these bacteria. So believe it or not, there are bacteria living on just about any surface that has some kind of food for them eventually. So here's a little scanning microscope look. You can see all those, what are these? Cocci, right? Living in these fibers of what looks like some kind of plant. It's quite amazing. So with these bacteria, considering the fact that 35% of these bacteria can survive transit through the stomach, that would make me believe that perhaps God intended for us to have some of these colonizing our intestine, right? Perhaps these are really what needs to be there. And that being said, I'm going to read some studies here that kind of bring this concept home. I'm going to look at Canadians first of all. There was a study that was looking at Canadians who were living in a urban environment, and it compared them with those rural Japanese that were consuming a traditional Japanese high fiber, rich in vegetables and a little bit of fish. What they found was that the Canadians had much poorer bacterial colonization of their intestines. They had species that were not so desirable as compared with those in the rural Japanese setting. There's another study that found that individuals residing in Tokyo, which is a huge city, compared to these elderly rural Japanese, maintaining a high fiber traditional diet. Now, what's the key here? I just said it. High fiber. And we as a country, we are devoid of fiber. We consume much less than even the recommended daily intake of fiber. We don't even reach the halfway mark of the recommended intake of fiber from the American Dietetic Association in general. We're in trouble in this concept. So with those living in the city compared with those living in the rural environment, which ones do you think had the better bacterial colonization? Those living in the rural environment. And across the board, all the studies that I've seen that compare urbanites with people living in rural areas consuming more of the fresh fruits and vegetables, these people have much healthier colons, much healthier colonization there in the colon with these bacteria. So let's talk about one strain of lactobacilli that I'll submit to you, this is my favorite strain. And there are a number of reasons why. This is Lactobacillus plantarum. It's found to have a number of different functions in our physiology overall. It's an antioxidant in some ways. It produces antioxidant chemicals. It helps to even prevent or reverse leaky gut or impaired intestinal permeability, and can lower the way in which our colon deals with toxins. So it actually can help even prevent leaky gut related symptoms. So it's a really wonderful probiotic bacteria. Here's a study that looked at Lactobacillus plantarum. In particular, how it interacted with the Western diet, which is a high-fat diet in most cases. What we find here is a normal diet. We have plasma cholesterol that didn't get too high, didn't change too much, which is normal with a normal diet. I'm not advocating a high-fat diet, but I just want to show you this, that with a high-fat diet plus this probiotic, which was the Lactobacillus plantarum, and one more strain, which is Lactobacillus curvatus, what it found, the study found, was that actually you did have some increase in cholesterol, but eventually you started to have a decrease with this probiotic administration after 18 weeks. Now here's another one looking at leptin. Leptin is our fullness hormone. A lot of times we have high leptin in the Western world, yet we're still hungry. There's something wrong with the receptors. And this is starting to happen right here. It shows that a high-fat diet can cause this problem. But with the probiotic administration, the leptin didn't get so high. Now over here is quite amazing. What we have here, the normal diet, before and after, plasma insulin. Insulin, high levels of insulin are characteristic of something called metabolic syndrome. Metabolic syndrome is the precursor syndrome. May take a few years to get there, but it's the precursor syndrome to cancer, heart disease, diabetes, chronic liver disease, chronic kidney disease. It's kind of like the stretch of time, the syndrome, stretch of time it takes to develop one of these diseases. And it's characterized oftentimes by high insulin. And the high-fat diet can do that. In fact, there was a study that showed in a group of healthy young men, or actually two groups, one group was fed a high-sugar diet, and the other group was fed a whipping cream diet, which is a high-fat diet. after a certain amount of weeks, the group that was taking the sugar, I don't know what happened with them. They probably were very excitable, but they didn't have any problem metabolically speaking. But the group that consumed the high-fat diet, they developed diabetes, type 2 diabetes. Healthy young men. Why? Because all they were eating was fat. Now, when they took the diet away, the diabetes went away. It was known as chemical diabetes because it was this added chemical that was causing this problem, and that chemical was fat. So fat can definitely cause problems with increasing the diabetic condition. But here, we see that this is the high-fat diet right here causing these problems, and the normal diet is right here. So obviously, the normal diet is the best diet, right? Which is a high-fiber diet, a diet that's rich in fruits and vegetables and whole grains. But with this high-fat diet and the probiotic, look at what happened to plasma insulin. It actually started to decrease. So these probiotic bacteria provide us with a lot of help in a lot of ways, ways that we probably never even imagined. If you have a desire to reach ideal weight, which most of us do, we need the right bacteria to help us. I'll give you another example here from this same study. It's kind of hard to see, but I'll just briefly tell you what's going on here. This is the normal diet, and we have the fat cells, the adipose tissue, which are kind of the containers that we store extra nutrients in. Who would like to have more fat cells? Okay, no one's hand went up. All right, so this is important to you. What happens here is these fat cells, not only can they duplicate or differentiate and turn into, instead of one fat cell, you have 2 or 4 or 8. They kind of go at an exponential rate there. Not only can they do that, but they can also increase in size. And usually they increase in size first before they split. That's kind of a marker for them to need to divide up and make more storage houses for us, right? But this is what happened with the normal diet. The fat cells were relatively small. You can't see it too well, but they're very small. And every now and then you have one that's a medium size. Now here's the high-fat diet. They had very large fat cells. What is that indicative of? Obesity, right? If our fat cells are enlarged, imagine how that translates out, right? So high-fat diet in some people especially will trigger this, but even high-sugar diet can increase the size of fat cells as well. But check this out. High-fat diet plus placebo. Many of these cells are regular size. There are a few that are a little bit larger, but it in no way compares to the, this one right here. Yeah, this one is the high-fat diet plus placebo. These are larger than these right here. So this in no way compares to the probiotic size fat cells. These fat cells are much smaller in these individuals that were given the probiotic. Isn't that interesting? So the probiotic bacteria can help with the metabolism or the utilization of fat. They can help prevent, in some cases, the growth of fat cells. That's good news, isn't it? Did you realize by the year 2025, 50% of the United States population is projected to be obese? 50%, that's 1 out of every 2 individuals. And couple that with the fact that over 25% of Americans are struggling with depression or anxiety or some type of mental illness, we are a society that's in trouble. We're in trouble because these things are not, it's not going on a downward slope. We're going on an exponential increase in terms of these chronic diseases. And I'll submit to you, a lot of times we overlook things in terms of scientific information and so on, but I'm really happy that so much focus is being placed on the microbiome and on probiotics in this day and age, because we need to understand this. We're years behind where we should be because of a few men's decision that we should stop studying this. For decades, we kind of turned off the light and we lost touch with what's really going on there in our colon. But I'm so thankful that now we're getting back on track. We're realizing that there are truly things that can affect us in a very negative way that are going on there in our colon. And we can do something about it. We can actually change, in many cases, not only the bacteria, but we can even change the health of our colon and how it interacts with those bacterium. And so as we look through the next couple nights, I just want to give you some ideas of what we're going to be talking about. Tomorrow the topic is called Food and Mood. We're going to be looking at some more of this information, but how it interfaces with the foods that we eat and what foods we can eat that potentially could give a better benefit to our gut health and promote the growth of these positive bacteria. We're going to talk about some of the more common forms of fermented food and see which ones of these could be the most ideal and which ones could be possibly not so good. And we're also going to be looking at factors, even lifestyle factors that play a role on the health of the colon, because there are even thought patterns that can damage the colon wall. And so we're going to talk about things like that, especially going into our last presentation, the gut-brain connection. We're going to be looking at how our thoughts affect the colon and even affect the bacteria that live in the colon. So it's not all what we put into our mouth. This is also what we allow to go on in our minds that can really have either a positive or a negative influence. And I'll submit to you, people are hurting, whether they be elderly adults, whether they be young children. People are hurting because of lack of information on the subject. We even have some cases of autism disappearing because parents are realizing, not everyone, not every case, but some cases of autism disappearing because parents are realizing, hey, it's this bacteria, or scientists are realizing, hey, it's this bacteria that was producing those chemicals that were interfering with the thought processes of my child. Okay, it's mind-boggling. It's amazing. And I hope that tonight you got a little bit of a taste of some of this good information. I'll submit to you, it's going to get better and better. And I want to encourage all of you to come back tomorrow night, which we're going to start at 7 o'clock tomorrow night, and then also on Saturday at 2 o'clock. So I want to invite each and every one of you. Please bring your friends and your enemies as well, okay? The Bible says we should love our enemies. Bring everyone that you can get a hold of, because this is information that we need to understand ourselves and we need to spread, because we're far behind. Even with all this recent information on probiotics, we're still far behind where we should be in our understanding and our utilization of this information. Okay? So we will see you tomorrow. Yes, question here.
You talked about the bacteria being on the fruits and vegetables.
Yes.
But what if you wash them really good today?
That's a good question. If you wash them really good, and especially this is how I used to wash my fruits and vegetables. Spray some vinegar water on them, and oh yeah, you just get them real nice and as sterile as you can get, basically. Well, by doing that, we are killing those bacteria. By irradiation and all these things, we want to prevent our food supply from being contaminated, which is a good thing, but we're also getting rid of these better bacteria as well. We're going to irradiate our foods to prevent the spread of E. coli. We're also going to prevent the spread of lactobacilli. So, yes, I'll submit to you what we've done is we've started washing less. Maybe we'll wash with water and give it some vigorous scrubbing to get all the dirt off of it, and maybe the primary contaminants, which if someone touched it and they had E. coli on their hands, yeah, I'd like to wash that off. That's fecal-based, so I'd like to wash that off. But to get real deep down in the crevices and get soap out and vinegar and all, I don't bother with that anymore. That being said, if I knew my vegetables were contaminated with some kind of deadly bacteria, I probably would do that. But that's not the case for most of our food supply. So yeah, it's a learning process, but it's something that can be easily applied once we know the reasons why. Thank you.
Thank you so much. Who learned something new tonight? Like I said, he's had a few months since May, and he has added some new interesting information. So there was some new stuff for me too. Well, as Ron already said, what time is everyone going to be back here tomorrow? 7 p.m. And then the last part of this series will then take place Saturday afternoon at 2. But I'd also like to invite you, Ron will also be giving our Sabbath sermon here at the church, which Saturday, the church service starts about 10:45, so you're more than welcome to join us for that. And then there will be a potluck in between, and then the 2 o'clock meeting. And if you weren't in the fellowship hall earlier, there's a free copy of the Amazing Health Facts magazine if you would like to take one and take an extra one and give to a friend. Ron has actually written 7 of the 8 articles in this, and I do have a few in Spanish, so if you have a Spanish-speaking friend that you think would benefit from the information, go ahead and grab one for them. And tonight as we leave, Ron and his family do these seminars. The church here is paid for his lodging and things like that, but he comes essentially for free. And this is how he just this is one of many of these health topics of these seminars that Ron goes around the country, and he's been around the world. And so one way that his family supports themselves is through love offerings. So this is free, you're not obligated to give, but as you leave there, my sons have some baskets if you'd like to leave a donation to help them to be able to continue to do this full time and to share this information that is so beneficial for us in this time. So let's see, so tomorrow at 7, Saturday at 2, and the magazine, oh yes. And also in the fellowship hall, if you didn't have a chance earlier to look at the materials that Ron brought, he does have some DVDs and some different, I think some like tinctures and salves that are for different health things. Feel free to stop by the fellowship hall before you leave and take a look at those. And if you'd like to purchase those, that also goes to help keep this ministry going. So you're dismissed, and we'll see you tomorrow at 7. And if you can, bring a friend. Good night.